Hello class, welcome back. Today we're going to go ahead and get started on section 6.1, right? Section 6.1. And this is the normal distribution, right? The normal distribution. So the main the main part, right? The foundation of this section and what's moving on, what's going to be coming up forward is analyzing the normal distribution curve, right? So, and by that, I mean the one right here, right? So during unit one, we were dealing with, right, with this normal distribution curve where 0 in the middle, right, that is going to be your mean, right? That's going to be your average. And we were talking about, right, how you can get a certain amount of you can move a certain amount of standard deviations to your right, right? Like this would be 1 standard deviation, this would be 2 standard deviations, and 3. And similarly, right, we would work backwards: negative standard deviation, negative 2 standard deviations, and negative 3 standard deviations, right? So we're going to go ahead and learn about how to read these values, right? So when you're finding these z-scores, right? When you're finding these z-scores, you're gonna want to go ahead and get the area under that curve, right? So for example, if you were to ask to find z equals 1.3, right? Z equals 1.3, how you read this table. And by the way, this is table E, right? This is a table you are not gonna have to be memorized. Of course, that'd be crazy, right? It's so many numbers, but this table will be provided during exam 2. Right? So let's just say that you were asked to find the value of whenever z equals 1.23, right? So the values you're going to be, honing in on, right, are going to be on this left-hand side, right, that z. And you'll find out that these values, these z values, are bounded between negative 3.4 and positive 3.4, right? So this table would give is bounded between negative 3.4 and 3.4, right? With 0 being in the center, right? So if I were to ask you, hey, what is the value whenever z equals 1.23, right? You're going to scroll down, right? This is one page is going to be the negative values, the other page is going to be the positive values, and I'm going to look for 1.2, right? I'm going to look for 1.2, and it's right here, right? This row here is going to give me the first 2 digits. That 0.03 that's missing, right, on the other place, you're going to find it up here on the top column, right? So if you're looking for 0.03, right, that would be up here, right, up there, right here. So in other words, to find the z value for z equals 1.23, you're going to go ahead and find the intersection, right? So if 1.2 is here and 0.23 is there, right, 0.03 is there, then the value I'm looking for is here, right? So the value for whenever z equals 1.23 is 0.8907, right? And we'll go ahead and find out what exactly does that mean, right? So if you were to be asked to find, let's just say, negative 0.02, right? Negative 0.02, you're going to look for the first 2 values, negative 0.0, right? And let me go ahead and clear this up, right? Right, I'm looking for negative 0.0, right? There we go. Need more space. Oops, sorry. There we go. Right. Go ahead and clear this as well. So what the value that I'm looking for is negative 0.0, which is going to be here, intersected with 0.02, which is there, right? So the value whenever z equals negative 0.02 is 0.4920, right? And that's the value you're going to go ahead and provide, right? So this is how we use the normal distribution table, sometimes referred to as the z table, right? So, right, you're going to be asked to find, so pretty much what we're going to be doing is finding areas under this curve, right? Areas under this curve. So, right, there's going to be three different possibilities. All right, you're going to have three different possibilities. If you're asked to find the area to the left of the z table, right? If you're asked to find the area of the z table, all you would have to do is locate that z value, and that z value is going to give you this entire area, right? The z value is, let's go ahead and get a highlighter, right? Pink. Right, so if you were to look for z equals, right, you want something greater than 0, let's just say like the one we found, z equals 1.23. When you give that number, it's going to give you the entire area under this curve. Right, it's going to give us that entire area under that curve. It's going to give us that entire area under that curve. Right, and again, right, if you were looking for a value in the negative region, right, it's going to count everything from the farthest left point up to here, right, and that'll be the area under the curve. If you're asked to, and right, and this is whenever when you want to know the area to the left of that, right? So things are going to be changed a little bit. Oh, and just real quick, the area from the very end to the very front is 1.0, right? 100%, right? 1.0, right? If you're asked to find everything to the right of a certain point, right? So if you ask everything to find to the right of a certain point, you're going to do 1 minus whatever that intersection value was for, let's just say, negative 2.50. Right? Because you want everything to the right of that, right? Because if you just gave that value, you're saying, hey, the value that I found is everything to the left of it. But that's not what I'm looking for, right? That's not what I'm looking for, right? And if you're asked to find the area between two z values, right? The area between two z values, you're going to get the larger z value, right? You're going to get the larger z value, or in other words, the value most furthest to the right, right? And now for simplicity, I'll go ahead and call that z large, and you're going to subtract z small from it, right? The point to the left of it. All right, and why, right? Why would you do that? So let's just say that I want to find the area between this is z equals, let's do something much more simpler. Let's do, it's going to be my average at 0. And let's just say here, this is z equals 1, right? And let's just say this is z equals 3, and you're asked to find the area between that curve, right? You're asked to find the area between that curve. All right, so what you would go ahead and do is you're going to find the area, sorry about that, you're going to find the area of z equals 3, right, which is going to include all of this, all of that, right? It's going to include all of that. Second, there we go, something like that. It's going to include all of that. And then you're going to subtract the area that's at z equals 1, right? So in other words, you're getting the full area and then subtracting what you don't want, which is going to give you that middle area, right? Or your main focus. So in other words, remember, you want your focus on the farthest right point minus the farthest left point. All right, so z large minus z small will give you that area. So let's go ahead and apply that, right? Let's go ahead and apply that. Let's go ahead and apply all these scenarios, right? So you're asked, hey, I want you to find the area to the left of z equals negative 2.31, right? So this means, all right, let's go ahead and draw this for, all right. This means if this is z equals 0, right, you want something about right there, right? You want all this area. All right, so let's just say this is z equals negative 2.31, right? And when we say whenever you want everything to the left of it, you just need to read that z value, right? You just need to read the area to the left of that z value. So I'm looking for negative 2.31. All right, I'm looking for negative 2.31, and that's going to be negative 2.3, right? It's right there, but I'm looking for negative 2.31, so the value I'm looking for is right there, 0.0103. So in other words, that area for A is, what did I say? It is negative 0.0104. Oh, no, it's positive, right? Because area has to be positive, 0.0104, right? And that's all we're doing, right? So that is the area. For B, right, I'm now going to ask to find the area to the left of 3.01, right? So 3.01 is over there, meaning it's going to include all of that, right? And I'm going to read it as is because that's exactly what I want. I want the area to the left of all of that. And we know it's going to have to be a big number, right? We know it's going to have to be a big number. One thing to remember from unit 1 is if the area between here and here is 1, then the area between here and here is 0.5 or a half, right? And the area between here and here is also 0.5 or just a half, right? So that means if you're finding the area, right, for positive 3.01, you know that's going to have to be larger than a half, right? My value is going to be larger than 0.5, right? It's going to be larger than 0.5. So let's go ahead and see what happens. I'm looking for 3.01. Right, this is a negatives. I don't want those. 3.0, right? 3.0. And I'm looking for 1. And be careful, right? The first column is not going to be for 0.01. That's for 0.00, right? That's in case you were to ask to find just 3.00. You would use that one, right? So just be sure that you use this one here, right? That's 0.9987. And that's it. 0.9987. Right, 0.9987, and that's my area, right? Something very close to 1, right? Because it's very close to the farthest edge on the right, and it's greater than a half, right? It's greater than a half. So that's how you find areas to the left of Z, right? We mentioned finding areas to the right, right? To the right, right? So one thing I'm going to go ahead and do is I want to find the area to the right of negative 0.31. Right, for right of that. Right, I want all of this. Meaning, I know that my area is going to be larger than 0.5, right? It's going to be larger than 0.5. So whenever it's to the right, we have to do 1 minus, right? 1 minus whatever that Z value is, right? Whatever that value is at Z at negative 0.31. So let's go ahead and find that. Negative 0.3, negative 0.3, negative 0.31. I get 0.3783. 0.3783. Right? If you were to just use 0.3783, it is this area, right? Because it counts it from the left-hand side. That's not what I want. I want the other piece, right? I want the other part, right? So this is what we do, 1 minus 0.3783, right? And whenever we plug this into our calculator, right, we do 1 minus 0.3783. This gives me, right, for A, this gives me 0.6217. Hey, that area is greater than a half, so I know this is correct. Right. For B, I want to find the area to the right, right? I want to find the area to the right of 1.28. So let's just say that's right, somewhere right there. Z equals 1.28. I want anything to the right of that. And we know we're finding areas to the right of that. It always has to be 1 minus whatever that Z value is there, right? So we know it's going to be less than a half, right? So if you want to draw it, please go ahead, right? Draw it, right? And how this looks is your Z value is 0 at the middle, 1, 2, 3, as it goes to the right, and as it goes to the left from that symmetrical point, it approaches negative 3 point. What's the edge on our chart? The edges are negative 3.4 and positive 3.4. All right. So, right, I'm going to look for What was I looking for the area for? Oh yeah, well, for 1.28, to the right of 1.28. So I know that's going to be less than a half. So let's locate 1.28. No, this is the negative values. 1.28, 1.2 is here, and I'm going to look for 8 on top. 1.28 right there. That's going to be 0.8997. 0.8997. I want everything to the right, so I know it has to be 1 minus that. So 1 minus 0.8997 is going to give me 0.1003. Right, I know that's less than a half. All right, so that works. All right. All right, now we're going to go ahead and find areas between two curves, right? So areas between two curves, right? So for A, I need to find the area between z equals 0, right? So between here and negative 3.12. So I'm looking for this area. Right? That's not exactly half, right? That's technically not half of the entire graph. So I know it's going to be less than 0.5, right? It's going to be less than a half, less than 0.5. So the farthest left point, right, is going to be z equals 0, right? So in other words, this is going to be my z large. And this here, that z equals negative 3.12, that's going to be my z small. And we said if we want to find the area between those two curves, it's going to be the value at z large minus the value at z small will give me my focus area, right? Will give me the area I'm looking for. So let's look for z equals 0, right? Why is it z large? If it's 0, it's because 0 is greater than negative 3, right? And it's to the furthest to the right, right? So let's go ahead and find z large, right? And if you notice, I'm looking for 0.00, which is just 0, right? And it says the area all the way from the farthest left to the halfway point is a half, 0.5000, right? So this is 0.5000 minus z small, which is negative 3.12, right? Negative 3.12, negative 3.1, right there. Negative 3.12. Right, so that's going to be minus 0.0009. Right, so that area is going to be 0.5000 minus 0.0009, and that's going to give me 0.4991, right? And that's going to be my area, right? We said it was going to be pretty close to 0.5 because it's almost the entire half of that curve, right? But not quite there. Very nice. And now we're going to go ahead and do another one, right? Let's go ahead and do B, right? B is going to be find the area between z equals negative 2. Let's just say that's somewhere here. Z2 is there. And z equals 3.09. Right. We know that the farthest one to the right is going to be my z large. And the farthest one to the left is going to be my z small. So I'm looking for this complete area. All right. And we know that the formula is to find the area between a curve, right, between 2 points under this curve is z large minus z small will give me that area. All right. So let's find z large. What is the z score for z large? All right. I got 3.09. Let's go ahead and look it on that chart. And please print this out, right? Let's please go ahead and print this out. 3.0 with 9. That is, let's make sure we're on the right row, right? That is 0.9 yet. That is 3.909. That is 0.9990. All right, so that's 0.9990 minus z small, which was negative 2. Right, if it's just negative 2, I know that's negative 2.00. Negative 2.00, negative 2.00, right, would be 0.0228. 0.0228. All right, I'm going to go ahead and subtract that so that it's 0.9990 minus 0.0228. So the area under that curve, right, is 0.9762. right? And it's pretty much engulfing the entire curve. So that's what's pretty close to, right? It's really close to 1 because it's almost taking the entire thing. And it goes back, right, to that table I had shown that, right, certain percentages are engulfed within that, right, within those standard deviations, right? The closer you are covering an entire area, the larger, right, the larger area under that curve. All right, so let's go ahead and move on to finding probabilities. All right, finding probabilities. So let's just say that you're asked to find the probability between two z values. Well, guess what? That's going to be the same thing we've been doing. That's just finding the area between two certain values, right? So it's going to be the same thing, right? So in other words, if you're asked, hey, I want you to find the probability using the normal distribution with the probability being between 0.01 less than z, and that z less than 0. So in other words, you're looking for the area bounded between negative 0.01 and 0. All right. So again, if you want to draw it, I would highly recommend you draw this, right? This is z equals 0, and negative 0.01, that's just slightly to the left, right? That's just slightly to the left. So that is z equals negative 0.01, right? And we said to find the area between, right, to find the area between two z values, that is going to be z large minus z small. And we said it's going to give me the area, right? Well, guess what? This is going to be the same thing as z large minus z small is equal to that probability. All right, to that probability. So in other words, my z large is z equals 0, and my z small is negative 0.01. Right, let me go ahead and negative 0.01. All right, so let's go ahead and find z large first, which is z equals 0.0000, right? And we know that's always 0.500, right? So that's going to be 0.500. That is going to be 0.5000 minus z small, which is negative 0.01, negative 0.01, right? So I'm going to get 0.4960. Would give me that area, right? And if I plug this into my calculator, right, it'll give me my probability, my area, 0.5 minus 0.4960, and that's going to give me 0.004, right? So that's my probability, right? If you're looking for percentages, what do you do with this? Right, you multiply this by 100, all right? So this here would be 0.4%. All right, so that little area here, you know, takes up that is 0.4% of the entire curve, right? With the entire curve being 100%, with half of it, right, being what? 50%, being the other half being 50%, right? So it's still the same rules as the area, right? It's just going to be asked differently, right? So you may be asked, hey, find the probability of z greater than 0.77. Oh, it's greater. You want everything to the right of this, all right? That is 0, then 0.77, right, would be somewhere right there. You want everything to the right of this. So we know it's going to be 1 minus the z value at 0.77, right? So let's go ahead and find 0.77. 0.7 and 77, 0.77 is there. So that's going to be 0.7794. Well, what did I say? I just set it to. What is it? 0.7794, 0.7794. I want everything to the right of that, right? And it's since to the right of that, I know that answer has to be less than a half, right? Because that's the part I shaded in. It's less than half of the graph. So that's going to be 1 minus 0.7794. So the probability that I'm looking for is 0.2206. Or if we wanted this in percentage, right? This would be that it's considered 22.06% of that graph. All right. So, my notes here. Okay, let's make these here a little bit smaller. So the question here says, now the probability is going to be given to you, and you're going to have to work backwards and find that z value. All right, you're going to have to find that z value. So I'm told here, right, I'm told here that the area between this unknown z and between z equals 0 is 0.2324. All right, and I need to go ahead and find the z value that corresponds to this, right? So in other words, I'm looking for that z area right here to the left. One thing you know, it's if it's to the left of the curve, z, the value must be negative. The z value must be negative. All right. I know this is going to be the z large, right? And this is going to be have to be z small, right? And this goes back to that formula, right? That z large minus z small is equal to the probability or to the area. All right. So well, I know what the z value is whenever z equals 0. All right. We know that is 0.5000, right? And we can go ahead and back here and look it up, right? Right there. 0.5000 whenever z equals 0. I don't know z small, and that's all right, because I know the probability that was given, right? The area, the entire probability under that curve is 0.2324. What are we going to do now? Oh, we're going to go ahead and solve for z small, right? So let's go ahead and subtract this from both sides. And then what does that give me? Negative z small. Negative z small is equal to 0.2324 minus 0.5000. And this gives me negative 0.2676. All right. Divide both sides by -1. So z small, the z small probability value that I get is 0.2676. Remember, this is a probability value. This isn't the z, that specific z value that I'm looking for. So what I meant by working backwards is in the table now, in the middle, this is the value you're going to have to find. And you're going to find out what z value gave me that probability. All right, so that is 0.2676. That means I'm in here, I'm going to look for 0.2676. 0.2676, yes. All right, and you'll notice that with these, sometimes it's not going to be the exact value. Sometimes it may not be the exact value. You may have to choose the one to the left or to the right, and you're supposed to choose the one that's closest to your value. All right. So if I'm looking for 0.2676, 0.2676, 0.26, it's right here, right? And that corresponds to negative 0.6 and 2. So in other words, right, let's go ahead and do this while I have this here. This is the z, that lower z value is negative 0.62. All right. There we go. So in other words, z small is negative 0.62. Right? And we said, right, that anything to the left of it was going to be negative. So I know this is right. All right. I know this is correct. All right. Let's go ahead and do more of these, right? Another backwards one, right? Again, all right. You're asked to find the z value, right? Let's go ahead and erase this. You're asked to find the z value. And I know that it's going to be to the right, right? I know it's to the right, meaning that I know my z is going to be positive. And I know my z value is going to be positive. Furthermore, I know that this is going to be z large. And this here is going to be z small. Right? And this is my probability or my area, right? Don't mind this. Let's go ahead and move that out of the way. Meaning, right? Well, I know the formula is Z large minus Z small is equal to the probability. All right, Z large is, I don't know what that is. I don't know what Z small is, right? That is, whenever Z equals 0, that probability value is, we know it's 0.5000, right? This is equal to that given area or the given probability, which is 0.3212. All right. Again, I'm going to solve for Z here. This is, I'm going to add this to both sides. Right. And we get Z large is equal to 0.8212. Right. And remember, this isn't our final answer. We need to find the Z numbers that corresponds to that probability. And again, we're going to do the same thing. We're going to go ahead and go to the middle section, right? Because we're working backwards and look for 0.8212. Right, so it's going to go here. It's greater than half, so I know it's going to have to be here, 8212 right there. All right, so this corresponds with 0.92. All right, 0.92. 0.92. So in other words, Z large is 0.92. And that would be my final answer. And it's positive, right? I know that's to the right, so it's positive. All right, let's go ahead and do another backwards example, right? Oh, my notes. Right. Here, I'm told to find the Z values that, right, the same thing, right? But the entire thing is shaded, right? I know what that value is going to be. That's going to be the furthest left value that comes out in my score, right? That's going to be Z small. This value is going to be Z large. And this is my probability. And again, right, this is Z large minus Z small is equal to probability, right? To my probability. Okay, Z large. I don't know what Z large is though, right? That could be anywhere there, but I know what the lowest value is, all right? I know what that lowest value is, right? It's going to be the largest value to that end, meaning the farthest left point that I have, it's going to be negative 3.4, but it's not going to be this one here, right? It's going to be the largest number, right? Which is Z equals negative 3.49, right? So always remember that. Let's be careful with that, right? It's not going to be that corner one you see here. It's going to be negative 3.49, right? And that value, negative 3.49, is 0.0002. Right? In case you're wondering how and why. So let's just say this is negative 3.40. This is going to be, right, you can say negative 3.41, right, negative 3.42, and so forth, with negative 3.49 being the one in the farthest left corner. Right, which is equal to 0.1762. Again, the same thing, right? I'm going to go ahead and solve for Z large, meaning I have to add this to both sides, meaning I get 0.1764, right? And remember, this isn't our final answer. This is the probability. You're looking for the exact Z value, right? So we're going to go ahead and focus on 0.1764. 0.1764, right? And this is what I was saying. 0.1764, is that closer to 0.1762, or is that closer to 0.1736, right? Again, right, the one we're looking for is 0.1764. So 0.1764 is closer to this one. So you're going to use that one and not 0.1736. So since it's closer to this one, this is going to be negative 0.93, right? Negative 0.93. What did I say? I just said it to negative 0.93. Right? And again, right, the Z value here, right, that was to the left of 0, right, to the left of the mean, to the left of the average, to the left at z equals 0. So I know that's going to be a negative value. All right. So now you're asked to find two z values so that 46% of the middle area is bounded by them. All right. It's bounded by them. Let's go ahead and make these. I apologize. I thought I had gotten rid of these. All right. So, right, if this is symmetrical, right, it's not kind of warped, but we'll say it is. You want, right, the 46% of this, all right? So something like this. You want 46%, all right? You want 46%. What that means, right? So in other words, you're looking for a z value that corresponds to here. We'll call it z1 and or z large even, right? z1 or z large, it's up to you. And I'm looking for the other z value here, right? So we'll call it z small or z2, right? Since I know this value, right? This is z equals 0, and that's right between it, right? That's since this is symmetrical, I know that this here is 23%, right? If the entire middle piece is 46%, then half of that is just 23%, right? Meaning that, in other words, this is 0.23, right? That area is going to be 0.23. That probability, right? 0.23. So in other words, I'm looking for, right? Let's focus on these two, right? I'm going to go ahead and focus. I'll worry about that z small later. I'm going to be worried about specifically this area, right? Meaning, right, this is just like the ones we were doing earlier, right? This here would be my z large, and this here would be my z small, right? To find that area, all right? So in other words, this is z large minus z small is equal to probability. Z large, I don't know what that z large value is, but I know what what the probability is at z equals 0, right? That is 0.500 is equal to that probability, and I know what that is. That's 0.23, right? That's 0.23. And similarly, I'm going to go ahead and solve for z large, and that's going to be, right, 0.23 plus 0.5. This is going to give me 0.7300. All right. So that means, again, I'm looking for the z number, not the probability. So I'm going to look at my table, and I'm going to look for, what am I going to look for? 0.7300. So and I know it's to the right, right? I know it's to the right of z equals 0, so I know it's going to be on the positive end. And I'm looking for 0.7300. Ooh, right? So my possible values are these, right? 0.7300, it's between those two, but which one is it closer to? Is it closer to 0.7324, or is it closer to 0.7291? Right? Well, I see that it's closer to the one on the left, right? It's closer to the one on the left. It's 24 away from the right, but it's only 9 away from the left. So the z value I'm looking for is going to be 0.61. All right, that's going to be the z to the right, right? And right, one thing you can say, since this is symmetrical, right? If this is, right, I know this entire thing is symmetrical, right? If this is z equals 0.61, what is this going to be? Equals negative 0.61, right? If you said, hey, do I need to find the one on the right? No, you can do the other way, and you would see it's going to give us the same answer, all right? You would, right? So what you would end up doing is, if you wanted to focus on this end, right? Again, that area, that probability is still 0.23, right? That's still 0.23, right? So what you would do here is, this is your large. This would become your small, right? And you would do z large minus z small is equal to that probability. I'll leave this as an exercise for you to find, right? So you can use symmetry, right? Or you can solve it manually doing the other way, right? And oh, that's the last example. This is all I have for you all today. Thank you very much, and I hope you enjoy the rest of your day. Thank you.